Hi guys, this is Mrs. Watson, just doing my Chapter 7 test review. I do hope that you're studying tonight and hopefully putting information into your notes. I thought I'd go through some of the questions a little bit more in detail, so if you do have questions, you can refer to this and hopefully that will help you. So the first question I'm going to do is number 1. Number 1 does say, actually numbers 1 through 3, you may choose 2 out of the 3 questions to complete. If you do all 3 questions, you will receive extra credit. I suggested in class on Friday that you do numbers 1 and 3. I will promise that the pictures for number 3 will look a lot better than they did on Friday, but remember the key to these questions is listening and looking and reading just what the question is giving you. For instance, in number 1, in A, it says my quadrilateral has 3 right angles. So it has 3 right angles. Now, if you look at that word, you can see that it does not say it has only 3 right angles. So it just has 3 right angles. And if you look at your shape sheet, you can see we have 2 shapes that have at least 3 right angles. So I would say that what it must be and what it could be would either be a square or a rectangle. And we talked about how a square is different than a rectangle because it has 4 equal sides. Since this question says nothing about the sides, we have to assume it must be a rectangle. It could be a square because a square does have those angles, but since we don't have that extra piece of information saying that it must have 4 equal sides, we'll have to stick with it must be a rectangle. It could be a square. The next question in number 1 is letter B. And so it says that, and you know how I am with writing on these, it's going to take me a second. My quadrilateral has a pair of parallel sides. So we have lots of different shapes that had parallel sides. And so what I would suggest that you look there and you see is that parallel sides. That's the only thing it says. If I look at my shape sheet, all of my shapes that have a pair of parallel sides have other things on that. The only shape the only piece of information we have is it must have a pair of parallel sides is a trapezoid. So it must be that because that's the only piece of information they gave us, a pair of parallel sides. What could it be? Well, it could be a right trapezoid. That was one thing we talked about. The reason that it must be a right trapezoid, remember, is because that has a right angle. And the information given to us is just a pair of parallel sides. So it could be a right trapezoid, an isosceles trapezoid. Again, that has more information than just a pair of parallel sides. It could also be a parallelogram. It could be a rhombus, a square, or a rectangle. So remember, you have to look at what is the information they are giving you. Must be a trapezoid, could be a right trapezoid. All of the ones for could be have more pieces of information, and that's why they can't be in the must be. The last one that I had on this question was my quadrilateral has a pair of equal sides and a pair of parallel sides. And I'm going to abbreviate with the parallel symbol so I can save room on this page here. Equal, so it's a pair of equal sides and a pair of parallel sides. Remember, a pair is only 2. So a lot of people wanted to say parallelogram for it could be, or excuse me, for it must be. Remember that a parallelogram, it has 2 pairs of equal sides and 2 pairs of parallel sides. This says just a pair. And the only one we have for that is the isosceles trapezoid. So be very, very careful. If you're struggling with what those words like a pair means or anything, just remember you have a pair of hands. I know this sounds strange, but I have a pair of hands, and there's not two pairs of hands, okay? So think about it that way. Let me know if you're so confused. Look at your shape sheet. That's going to be a huge help for you. Now, it could be several things. It could be a parallelogram. I'm going to abbreviate here. It could be a rhombus. Could be a square or a rectangle. Okay? So I will be honest, these questions on your test were the same ones, but just remember to read the information that they gave you. Okay? You've done several warm-ups. You've done several of these just throughout this chapter. So just be very careful and read the question. You have more than enough time. And number 2, it is a challenge. But I suggest that you take that challenge and you answer that question as an extra credit. It is difficult, but I think you can do it. In number 3, I'm not going to do number 3 for you on here, but I would suggest that you have all markings on the shapes on your shape sheet. Okay, and the reason that I'm saying that you do that is, for instance, if I gave you a shape that looks like this, and I see that I've got my parallel markings, I would automatically assume that this is a parallelogram. If you don't have these markings on your paper, it's going to be very difficult for you to know because I'm just giving you a picture with that information. Okay? Be very diligent about looking at the information when you're doing it. Okay? So that's one really, if you have your notes for your shape sheet, you'll be fine for that. Okay? In the next set of questions, we have numbers 4, 5, and 6. There will be 4, 5, 6, and 7 on your test. You only need to do 2 out of the 4. So if there's a proof you really like, go for it and do it. Information for some of them and not for some of the other ones. I'm going to go through number 4, okay? And I would suggest that you make sure everything is on your paper. So in number 4, we have this nice shape here, and they gave us some information. W and Y, Z, angle Z is equal to angle X, and opposite sides are parallel. Okay? The biggest thing I see people do is they don't read their given. Okay? And here's what you're given. You're given that WZ is parallel to XY, and we can see that right here. WZ is parallel to XY. They gave us that information. They also said that angle X is equal to angle Z. And I see that information right here and right here. Just because it's parallel does not mean it's equal. And I hope that we have really gotten the difference between those two things. Okay, we want to prove that we have triangle WXY is congruent to triangle YZ and W. Okay, so we see the two triangles right here, and this line is separating the two. We want to prove that those two triangles are equal. So the first part in the flow chart says that WZ is parallel to XY. And we know that information, the justification would be the given. Okay? The other piece of information that they gave us the justification, and we need to fill in what the conclusion was. Well, there's two parts to our given. So the other given we have is angle X is equal to angle Z. Okay, now let's take a look there. We can't really do much with those angles, but we can do something with the fact that we have parallel sides, and we have that picture, and we know this about the opposite angles. And look, that's what our next thing is. It says if opposite sides, I'm really going to abbreviate here, are parallel, then alternate interior angles, that's what AIA stands for, are congruent. Okay, so what does that mean? Well, we need to find the parallel sides. You see we've got WZ and we have XY. And so since these sides are parallel, the opposite angles, I'm going to put a little line here for it, are equal. Okay, see how we have those opposite angles there. Now you really should be using 3 letters. In fact, I will mark it off if I don't see that. So what I would say here is that you want to do angle XWY is congruent to angle Z. No, wait. Oh, Mrs. Watson just did that one wrong there. Sorry, guys. Let's try that one more time. Angle XYW is congruent to angle ZWY. Okay? Now they also said that the sides in the middle are equal to each other. And we know that anything is equal to itself by the reflexive property. Okay, so WY is congruent to YW. Okay, so now let's look at that. Knowing that the only way we have to prove triangles are congruent is with one of our 5 shortcuts. We have an angle, another angle, and a side. And I look through my notes, I see that I've got 5 different ones. An angle, side is one of my shortcuts I can use. And have I answered that to proof? Yes, I have. So on the next, so that you can see this right here. So the last thing that we have in our flow chart is angle, side congruent, and we have triangle ZWY is congruent to triangle XYW. Now, if you're confused if your order is correct, what I can do for you during your test is I can tell you if it's incorrect. I won't tell you if it's right, but I will tell you if it's incorrect. I hope that you can assume from there what's going on. The next one I'm going to do is number 5. I won't be doing number 6 because I'm only doing 2 out of the 3 because you can get some extra credit. I do encourage you to try number 6 just because I think it's really important that you can do a proof without some extra information, so without someone starting it. If that's something you can't do, that's why it's extra credit, but it's always good to stretch ourselves just one step further. So let's look at it right now. And number 5 has this really strange triangle that tries to be 3D, but really isn't. It did try really hard though. So I'm going to label every part of it. And yes, I know my triangle could be a little bit better, but you have this in front of you hopefully, so you'll be okay. So we are given, in number 5, it says that we are given that TC is congruent to TM. Okay, and then also that AT bisects angle CTM. So I'm going to make sure that that's marked on my paper. Remember, a bisector cuts an angle into 2 equal parts. Okay, so you want to be really careful that you remember what that bisector is cutting. So many people want to say, oh, the definition of a bisector is AT. Remember, in the given, it's telling you that it's bisecting angle CTM. And we're trying to prove that CA is congruent to MA. Okay, so let's start off with these conclusions and justification. Remember, I'm going to give you a flowchart proof, and I'm also going to give you a 2-column proof. So I hope that we are good at doing both, but I know that some of us see things differently. So definitely you are open to the different options. That's why you're choosing problems you want to do. So the first step we know is always the given. So it says TC is congruent pardon me, to TM, and that AT bisects angle CTM. And the justification for that is it was given, okay? Every problem has some information that they give us. That's what was given. Okay, in step 2, it says definition of bisector. Remember, a definition of a bisector is it splits something into 2 equal parts. Well, the only thing that was split into 2 equal parts, as we saw in the given, was that angle. So now we know that we have an angle that's equal, because that's what a bisector does. It splits it into 2 equal parts. So then we can assume that angle CTA is congruent to angle MTA. This is the one where I see people say they just want to write down AT. Well, we know that the bisector is AT, but that's not what the definition of it is. The definition is that it splits an angle into 2 equal parts. So it is important that we know that. The next thing on your paper, it says AT is equal to TA. I will go to the next slide and write this down, but we know that that means it's the reflexive property. Remember that if we want to prove some parts of a triangle are congruent, if we can prove those triangles are congruent, we can then prove the other sides and angles that we haven't touched yet, are also congruent. So it looks like we have 2 congruent triangles. I see side angle side, side angle side. So let's go to the next. Need some more room here. Let's finish writing down what we need to. Step 3, it says that AT is congruent to TA, and we know that that's always by the reflexive property. And we also know, we just said that these 2 triangles are congruent by side angle side, so let's write that down. And triangle CTA is congruent to triangle MTA. And then once the triangles are congruent, all the other parts of that triangle are congruent. So I now know that CA is congruent to MA by the CP-CFC. And remember, that stands for corresponding parts of congruent triangles. And we're going to say figures, because it's not just triangles, are congruent. Okay? Also, if you're doing this and you're listening to this and you're saying, Mrs. Watson, this is great, but I need to look at a paper and I don't have mine, if you look on the Chapter 7 page of the geometry tab on the website, there is a copy. You can print it and download something that's similar. I did add a couple things by pen, but hopefully it's pretty good for you. So the next problem we have is number 7. And so let's start that one. Let's say to graph. I'm not going to show you how to graph because I feel like that's a skill I'm hoping you know how to do. If it's something you're struggling with, feel free to send me an email. It's nwatson1@pps.net. I'll try to check that later tonight, and I can just write it out for you. But remember, X, then Y. So you're going to graph it first on graph paper. Part B, though, says to find the midpoint. And remember, this is just, I hate that term plug and chug, but that's really what we're doing. We're using this formula. x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Okay? And here's the points that we have. We have -4, -11, and we have 5, 1. Okay, remember that x1 and y1 are just your first point, x2 and y2. This is such a struggle for some of us to know what to label. Just put it on there. It's okay. A lot of us spend so much time, and if that's something you're confused on, just raise your hand. I can kind of direct you a little bit. But what you're going to do then is you're going to end up with -4 plus 5 over 2, and then you're going to get -11 plus 1 over 2. Looks like it's a -1. Yes. So let's make sure we have that. And the midpoint would then be 0.5 or a half and -6. Okay? That's all it is. This is the same way you're going to do 8. So I'm going to make a note of that. Do same for number 8. I'm not going to go through that because, again, sometimes I give you stuff that is just extra practice so that you'll go home and actually do that. The next one I'm going to do is letter C, which is, we said finding the length is the same as finding the distance. So let's look at that real quick here. So to find the length, remember D is equal to x2 minus x1. It doesn't really matter which one you put first. Just remember you're subtracting your x's, you're subtracting your y's, you're taking that difference, squaring it, adding the new answers together, and then taking the square root. So for our problem, it would look like this. 5 minus -4 squared plus -1 minus -11 squared. Minus a negative becomes a positive, so we get 9 squared plus 10 squared. And that gives us 81 plus 100, which gives us 181. And that says the distance is approximately, or the length is approximately 13.45 units. So, all good things to know. Let's look at the last problem, number 9. Number 9 says on graph paper, draw a quadrilateral, ABCD if A is 210, B is 413, C is 1013, and D is 810. Now, unfortunately, I had some typos, unfortunately, but that days. So we did say in part A we want to find the slopes of AB and CB. And then we're going to find the slopes of BC and AD. And then part B says, what is the best name for this quadrilateral? I know it does say MNPQ. We're going to change that to ABCD. And then it says Y. So again, I'm not going to graph this, but I will show you what the picture looks like for number 9. I don't have graph paper on here, but this is what it would have looked like. Here's point C, and remember C is 10, 13. And then we have point D, which is 8, 10. And we know that A is 210. And then we know that B is 413. Okay. So again, several people said this looked like a couple different things. Some said rhombus, some said parallelogram. That's fine, but either one we have to prove why. So for instance, if we thought it was a rhombus, we would have to show that all sides are equal, and they have equal lengths, which means they would have to have the equal distances. If we think it's a parallelogram, then we would have to show that opposite sides are parallel, which means that the opposite sides have the same slope. So I think that this looks more like a parallelogram than a rhombus. So I'm going to go that route. You can obviously go a different route. But the question asked me to find the slope of line AB, which again, slope, I'm going to write right up over here, is y2 minus y1 over x2 minus x1. Okay? So I get 13 minus 10 over 4 minus 2, which is 3 over 2. Okay? And then it asks me to find the slope of CD, which is 10 minus 13 over 8 minus 10, which is negative 3 over negative 2, which simplifies to 3 over 2. Okay? So it looks like for AB, those slopes are the same, which is great. That means if the slopes of the lines are the same, that they're parallel. But I can't stop there. That's one pair of parallel sides. And the question asks me, what quadrilateral does it look like? And a parallelogram has two pairs of opposite parallel sides. So I'm going to finish this question and find the slope of BC, which is 13 minus 13 over 10 minus 4, which is 0 over 4, which is just 0. Remember, if 0's on the top, it's okay. If 0's in the denominator, it isn't undefined. So AD is 10 minus 10 over 8 minus 2, which is 0 over 6, which is 0. So again, those two opposite sides have the same slope, so they're parallel. So I have two pairs of opposite parallel sides due to the slopes. So then the best name for this is a parallelogram. In letter B, I will expect a whole written explanation. Okay, so I'm going to say here shortly that's a parallelogram because opposite sides are parallel. You would need to write in complete sentences, and you need to tell me why they're parallel, and you would have to go through your steps. Well, I found the slopes of the sides that were opposite. The slopes were equal, so that means they're parallel. And I found that for both sets, and I know that the definition of a parallelogram is opposite sides are parallel. So the best name for this shape, quadrilateral, is a parallelogram. I hope that you enjoyed this. The rest of the problems are extra credit, helping us with our algebra skills. If you have any questions, again, don't hesitate to email me, nwatson1@pps.net. Otherwise, you can come in tomorrow morning. I'll be there right at 8. You're going to do great on this test. I've got high hopes, and I hope that reviewing like this will help you as well. Additionally, don't forget to check the Apple downloads. I don't think it's been reached yet, but I'll have to check on my phone. I'm having some internet problems at home. So I'll find that out, and I'll hopefully post that up for you. So have a great day. I hope you enjoy the rest of your weekend.